Here's a puzzle. Someone tells you they're thinking of a number. When they add 8 to it, they get 17. What's their number? You probably figured it out already. The number is 9, because 9 plus 8 equals 17. That little bit of detective work is exactly what algebra calls solving an equation. By the end of this video, you'll be able to solve any equation like this one using two simple properties. Let's start with what a solution actually means. A solution to an equation is a value of the variable that makes the equation a true statement when we plug it in. Take the equation x plus 2 equals 7. If we substitute 5 in for x, we get 5 plus 2 equals 7. That's true. So 5 is a solution. Let's try a checking problem together. Is x equals 5 a solution of 6x minus 17 equals 16? To find out, we substitute 5 for x and simplify. 6 times 5 is 30. Then 30 minus 17 is 13. So we get 13 equals 16. That's not true, so 5 is not a solution to this equation. Now here's the big question. How do we find a solution without just guessing? Let's use a picture to figure it out. Imagine an envelope with some unknown number of counters inside. On the left side of a table, we place the envelope plus 3 loose counters. On the right side, we place 8 counters. Both sides have the same total. How many counters are hidden in the envelope? To find out, we remove 3 counters from each side. That keeps things balanced. What's left? The envelope on the left and 5 counters on the right. So the envelope must contain 5. Algebraically, x plus 3 minus 3 equals 8 minus 3, which gives us x equals 5. That move, subtracting the same number from both sides, has a name. It's called the subtraction property of equality. In plain English, if two things are equal, and we take the same amount away from both, they're still equal. Our goal when solving is to get the variable alone on one side. Let's use this to solve x plus 8 equals 17. The 8 is being added to x, so to undo that, we subtract 8 from both sides. On the left, 8 minus 8 is 0, leaving just x. On the right, 17 minus 8 is 9. So x equals 9. Let's check it. Substitute 9 back into the original. 9 plus 8 equals 17. True. Our solution works. Now, what if the variable is being subtracted from, like, x minus 5 equals 8? We can't undo subtraction with more subtraction. We need the opposite move. That's where the addition property of equality comes in. It's the mirror image of the last property. If two things are equal, we can add the same number to both sides, and they stay equal. To solve x minus 5 equals 8, we add 5 to both sides to cancel out that subtraction. Minus 5 plus 5 is 0 on the left, leaving x. On the right, 8 plus 5 is 13. So x equals 13. Pause the video and try this one yourself. Solve 27 equals a minus 16. What move do you need? Since 16 is being subtracted from a, we add 16 to both sides. 27 plus 16 is 43. So it equals 43. Notice, it doesn't matter which side of the equation the variable is on. We just isolate it wherever it lives. One more skill to add, translating word sentences into equations. Words like is, gives, equals, and is the same as all become the equal sign. Try this one. 3 more than x is equal to 47. The words is equal to mark the equal sign. 3 more than x becomes x plus 3. And that equals 47. Now solve it. Subtract 3 from both sides to isolate x. 47 minus 3 is 44. So x equals 44. You just did real algebra. You know what a solution is, you can check whether a value works, and you can solve equations using both the subtraction and addition properties of equality by isolating the variable. Next time, what if the variable is multiplied? Does the same undo the operation trick still crack the equation?